Welcome to today's webinar, Amazon ECS Deep Dive. Our presenter today is Peter Dalbungen. He is a solutions architect for the AWS based in Herndon, Virginia. Peter has a keen interest in DevOps, microservices, and strongly believes one cannot coexist without another. At AWS, Peter helps with designing and architecting a variety of customer workloads. Today with us, we also have Andrew Thomas, who will be our webinar moderator today, be answering your questions throughout the presentation. So Peter, I'll hand the call over to you.
All right, thanks a lot, Jerry. So my name is Peter Dalbungen, and I'm a solutions architect for Amazon Web Services. Today we will be doing a deep dive on Amazon EC2 container service. Before we get started, like Jerry said, this presentation is being recorded, and the webinar and the slides will be made available to you in a couple of weeks. If you have any questions, please post those in the chat window, and I will do my best to answer those live at the end of this webinar. If you're not able to get to your questions, I would recommend to reach out to our forum posts. You can review our documentations, or you can reach out to your account teams. Just a quick reminder here, because this webinar is open to the public, we will not be able to disclose roadmap items associated with EC2 container service. You can reach out to your account management teams to facilitate those discussions under NDA. Let's get started. So here's the agenda for today. First, we will review a few best practices for setting up your ECS infrastructure. And then we will go and review how to better manage your ECS infrastructure. And in this section, we'll go and cover monitoring, logging, security, service discovery, and automated scaling. And then we will take a look at a few platform as a service that are built on top of ECS. And lastly, we'll do the Q&A. Just to level set our expectations, this deep dive is for folks who are already familiar with containers and are in a container journey. And we are assuming that you are already aware of some of the terminologies like ECS, tasks, task definition, etc. But I will be providing some basic info about each of the components to keep it informative for new users. So before we start with discussing best practices, I want to spend a minute or two and talk about Amazon ECS and its benefits. Amazon ECS is a cluster management system to run your Docker containers. So you can bring your Docker containers into AWS without the need to install or manage your cluster software. Now, ECS offers a reliable state management and flexible scheduling for your containers. And the state management could be the states of your EC2 instances or your containers that you run within your cluster. And the scheduling challenges could be collecting information about resource utilization such as CPU, memory. It could be starting and stopping your containers or choosing the right resource. Also, because ECS is offered as a managed service, it is constantly evolving and it's making it easier for you in your container journey. One of the benefits you get readily is integrating with other AWS services like AutoScaling, ELB, CloudWatch, IAM, etc. And when we built ECS, we wanted to make containers as a first-class citizen on AWS. ECS was announced during reInvent conference in November of 2014. So it's almost a 2-year-old service. And we have seen many customers run production applications using ECS. It's offered as a building block service. And we have seen good adoption across multiple third-party services, including our own Elastic Beanstalk, which I'll be talking about at the end of this webinar. Now, in order to set up your ECS infrastructure, you need a couple of components. You need a cluster defined with EC2 instances. We call them container instances. And you need a repository to store your Docker containers. Now, keep in mind, you can set up ECS infrastructure and ECR using the management console, as well as AWS CLI or SDK, which I have not highlighted here. But in the next few slides, we will see how these additional tools like CloudFormation or ECS CLI or Ops Works can help benefit you in your design as you set up your infrastructure. Just to give a little bit of intro about CloudFormation. CloudFormation is a provisioning service which gives developers and sysadmins an easy way to create and manage a collection of AWS resources. You can provision and update all of your resources in an orderly and predictable fashion. You can define your templates using JSON or YAML format, and you can version control them. So you know exactly what changed within your infrastructure. And actually, this practice is termed as infrastructure as code. So here's an example template that defines an ECS cluster and container instances in an auto-scaling group. So the recommendation here is to use CloudFormation if you're already leveraging this tool for your infrastructure provisioning. Another recommendation is to put your container instance in an auto-scaling group. This way, your ECS clusters can scale based on your application demand. We will be talking about scaling best practices when it comes to containers in a later section. And here's a launch config part of auto-scaling configuration. You can see that launch config leverages CFN init, which is a feature of CloudFormation, in order to execute a command to add your container instance to the cluster that we defined earlier. And here is a task definition for your container setup. Now, task definition is a text file in JSON format that describes one or more containers that form your application. It can be thought as a blueprint for your application. And tasks are the instantiation of a task definition. After you've created a task definition for your application, you can specify the number of tasks that you want to run in your ECS cluster. Now, in this particular example, we are specifying two tasks in our task definition. One is simple app, and the other one is BusyBox. We give both the tasks specific set of resources. For example, simple app has 10 amount of CPU units and 300 megabytes of memory. And BusyBox has 10 CPU units and 200 megabytes of memory. So after you've done authorizing your CloudFormation template, you can launch a stack, in which case you'll now have an ECS cluster with container instances in an auto-scaling group and the task definition defined. So that was one way to launch your ECS cluster. Now, if you're a command line user, ECS CLI may be a better tool for you. ECS CLI is a command line interface for ECS to simplify creating, updating, and monitoring clusters and tasks. Now, this is different than AWS CLI. AWS CLI is a unified client for AWS services that provides commands for all publicly available API operations. And one neat feature about ECS CLI is it supports Docker Compose. And Docker Compose is a tool for defining and running multi-container applications. For example, if you have a two-tier application like a front-end web server and a Redis container defined as a service, you might want to run and update both of these at the same time. And Docker Compose helps write your application as a single unit. So if you're used to developing Docker containers using Docker Compose, ECS CLI helps orchestrating those commands and creates task definition for you for those Docker Compose.yaml files. And this project is available on GitHub, so you can review the source code and use it according to your need. And here are a few examples of how to use ECS CLI. In the first command, you can see that you can go ahead and build your ECS cluster with 2 container instances in it, with IAM roles added to it, and with your specific key pair. In the next command, the ECS CLI is taking your Docker Compose.yaml file. It goes and creates a task definition for you, and it also goes and starts your tasks. And the next one is if you want to go and check how many tasks that you have running in your cluster, and so on. And here's another way to set up your cluster. And for those who are not familiar with Ops Works, Ops Works is a configuration management service that uses Chef to deploy your application. And you can leverage Ops Works if you already have a way of deploying software using Chef as a configuration management, and tie it back with ECS to get best of the both worlds. And the advantage of using Ops Works is to streamline your container instance provisioning and management, apply security patches to those container instances, and streamline your user permissions and several others. So that was about setting up your ECS cluster. Again, you can certainly set up your ECS cluster using the management console or the CLI, AWS CLI or SDKs. Now let's take a look at setting up your ECR. Just an intro to ECR. It is a Docker Container Registry Service, and this is where you would store your container images and you version control them. And by default, only you as the AWS account owner have read-write permissions to your repositories. But if you need to share your repos, you can easily do that by using IAM. Also note that you can have namespaces defined to your ECR repos. For example, if you want to call your repo as a team A/web app, you can easily do so and have your repositories based on your team members. And here are a few commands to be familiar with respect to ECR. First is you need to authenticate your Docker client with ECR registry. And when you run AWS ECR get login command, you get an authentication token. And you copy and paste that response in order to authenticate your Docker client with ECR. And then after that, you can go ahead and create your repos, tag and push your image into the repo as shown. Now, if you don't want to use Docker login command, as described earlier, you can leverage this ECR Docker Credential helper, which lets you authenticate with ECR by a simple configuration in your desktop. This credential helper is for Docker daemon, as it makes it easier to work with ECR. The neat thing about this is it uses the same credential as AWS CLI and SDKs. And this is also available on GitHub. Now let's move to the next section of this presentation, which is how do you better manage your ECS infrastructure after the cluster is set up? And we will be talking about operations and security side of the house in this section. We will review different options available to you for monitoring and logging, and then we'll discuss the strategies you can take in order to scale your ECS cluster resources. And we will review different techniques in order to do service discovery on ECS. And lastly, we'll review security. In this case, we will see how to apply proper permissions for your containers using IAM roles. So let's start with monitoring and logging. One of the service you can readily take advantage of as you start using ECS is the Amazon CloudWatch service. CloudWatch is a monitoring service for AWS resources. You get visibility into 4 available metrics automatically. And those are the CPU reservation and memory reservation. CPU and memory reservation is a percentage of units that are reserved by your running tasks in a cluster. And you also get utilization, and it is a percentage of units that are used in a cluster or a service. And here's a graph that is visible from the AWS Management Console. And this is a view from the ECR cluster level. Now, if you go into the service level, you get visibility into CPU and memory utilization at the service level. And you can also take advantage of CloudWatch dashboards. This is a feature of CloudWatch. You can go ahead and create a custom dashboard. And here is a dashboard that has CPU utilization from ECS, as well as healthy host count from ELB, and several others. So if you have a need to define additional metrics other than the 4 that I talked about earlier, you can certainly write your own and push it up to CloudWatch to monitor. You can write a script like this one. Here's an example to let CloudWatch monitor your disk space utilization. You can write the script and use CloudWatch to do a put API to register this metric. Once you start collecting your metrics, you can set up CloudWatch alarms and take actions if it breaches certain threshold. Now, CloudWatch Logs is another feature of CloudWatch. And in CloudWatch Logs, you can store, monitor, or access logs such as system or application logs in near real time. You can configure the containers in your tasks to send logging information to CloudWatch Logs. And this enables you to view different logs from your containers in one convenient location. And it also prevents your container logs from taking up disk space on your container instances. CloudWatch Logs get stored in S3 by default. But if you have a different set of consumers, then you can use the subscriptions feature, which is available through CloudWatch Logs, to get access to these events. And your consumers can be real-time analytics or processing services like Amazon Kinesis. It could be AWS Lambda or Elasticsearch service. And there is a pretty good documentation from Docker on how to enable CloudWatch Logs logging driver. And I highly recommend taking advantage of this if you want to send your logs into CloudWatch Logs. Here's an example snippet of how to enable CloudWatch Logs in your task definition. Now, another way to monitor your containers is by using Datadog, which is a third-party service. And what they give you is it enables collection, visualization, and alerts on important Docker resource metrics on Amazon ECS, such as CPU or memory usage. You can install the agent as a container, give it appropriate permissions using IAM so that it can start listening to ECS events. So now you can not only get Docker events, but you can also start monitoring ECS events. And when ECS brings new containers online, Datadog automatically begins tracking those metrics. And when the containers go offline, Datadog handles that event gracefully as well. Sysdig is another third-party application that can be used for monitoring. It can also be installed as an agent or as a container on ECS instances. You have to give appropriate IAM permissions so that Sysdig can start monitoring both containers as well as ECS events, and it will do both for you. Now let's take a look at some best practices to consider while you think about scaling your containers on ECS. Like we showed you earlier in setting up your cluster section within CloudFormation, it is highly recommended to configure auto-scaling for your cluster instances. And before you configure your launch configuration, it is important to choose the right instance size for your container instance at this step. Now, EC2 has a wide variety of instance types that are designed to fit specific use cases. If your application is compute optimized, you can leverage C4 instance types. If it is I/O optimized, you can use I2s. And if it is memory optimized, then you can use R3 instance types. And if you're not sure which instance type to start with, you can use M4 instance types, which are general purpose instance types. And once you decide the right instance type, you can choose the latest Amazon Linux ECS optimized AMI to get started with configuring your auto-scaling group. You can also use your own, your other distros like Ubuntu or Red Hat, and you can choose that and configure next steps. Within auto-scaling group, you can define your min, your max, and your desired number of instances to run, and start configuring your scaling policies to scale your cluster based on CloudWatch metric. Now you can automatically scale an ECS service based on any CloudWatch metric. For example, you can use CloudWatch metrics published by Amazon ECS, such as each service's average CPU and memory usage. And you can use CloudWatch metrics published by other services or your own custom metrics as well. For example, if you want to scale a web service, you could use the ELBs, that's the Elastic Load Balancing metrics, like search queue length, while a batch job could increase the number of tasks based on Amazon SQS metrics, such as number of messages in the queue. And a recent addition to ECS service is the application load balancing feature, which lets you specify a dynamic host port that gives your container an unused port when it is scheduled on an EC2 container instance. The ECS scheduler will automatically add the task to the application load balancer using that port. An ELB can also be shared among multiple services using path-based routing. Each service can define its own URL, and that URL routes traffic to the particular ECS service. Now previously, before we had this ALB integration into ECS, you had to define a fixed host port for your container to use in order to route ELB's traffic to your application. And that prevented multiple copies of the same tasks from running in the same host. There was also a one-to-one mapping between ECS service and ELBs, which increased the complexity of running microservices application on ECS cluster. Now let's take a look at a quick demo and see how you can configure auto-scaling in action. So here is my ECS cluster. And you can see I have a few clusters available in my in ECS. And the one that I'm going to use is ECS demo cluster. You can see I have 4 container instances that are added to this ECS cluster. And then I have one service defined. That's the demo service. And I have 2 tasks that are running for this service. And if I need to configure auto-scaling, I have to go within the service itself. Like I said, you have 2 task definitions available that are running and 2 desired comps. Let's go ahead and configure auto-scaling. We'll go ahead and click Update. And then we'll say Configure Service Auto-Scaling. We'll choose the radio button for Configure Auto-Scaling. And we'll go and say our minimum number, desired number can be 2, maximum number can be 4. And we'll go ahead and define the scaling policies in order to scale our container instance. Now, I've already configured my CloudWatch metric. You can see that as I define my scaling policy. I have 2 scaling policies here that are based on memory utilization. So the first thing I'm going to do is I will choose to scale based on memory. And you can see that I've defined my CloudWatch metric to scale when my memory utilization is 65% or above. And what I want to do is I want to literally double my container instances, tasks that are running. So I'll say go ahead and add 100%, which will double my tasks to 4. And I'll say I want to add those as an increment of 2. And let's go ahead and save this. And let's go ahead and define a scale-in policy. We'll give it a name. And in this scaling policy, I want to remove 1 task at a time when my memory utilization goes below 20%. So now we have our scaling policies defined. Let's go ahead and save it. You can see the summary of how the auto-scaling is defined. Now let's go ahead and click Update Service. You get a confirmation that the service is updated. We'll go and click View. And if you go and take a look at the CloudWatch metrics that I was showing earlier, this application is pretty high in demand. I'm sure it's going to go and scale, which is good for this demo. It's peaking at 67, 68%. And we should see the event saying service demo has started 2 tasks. Yep, there it is. And I have now I have a running count of 4 tasks rather than 2 tasks earlier. So that shows you how easy it is to set up your scaling of containers, and you can take advantage of this right away. Let's go back to our presentation. Okay, so that was scaling. What kind of best practices you can take in order to scale your containers on ECS. Now let's take a look at how to do service discovery and what kind of options do you have within ECS. And we'll talk about a couple of native services here. One is ELB and Route 53. And we'll also talk about a few third-party providers who have made it pretty simple in order to perform service discovery using ECS. Just to give a brief intro about service discovery is a reliable framework to describe the relationship between different microservices. It is a requirement for a microservices design pattern. For example, if you have a portal application that needs to communicate with the weather service in order to provide data, it needs to know how to connect with that service. So here is one option that is available to you where you can use ELB for service discovery. And we have a reference architecture implementation on this approach. And I will be providing all the resources at the end of the section, so and the slides will be available to you, so you can take advantage of these approaches and see how everything works. So in this reference architecture, we have all the automation that is built for you, and we are using CloudWatch events, Lambda, and Route 53 private hosted zones in order to give complete service discovery options on ECS. And this approach registers service names as a CNAME record pointing to your ELB in Route 53's private hosted zone. And if your containers need to communicate with that particular service, all it needs to know is a service name, and you can configure this using environment variables. Now, I spoke about a couple of services here, CloudWatch events. It's a feature of CloudWatch, and it actually captures near real-time stream of events within your AWS environment. And the resource could be EC2 instance state, like a change in pending state to running state. It could be auto-scaling scale-in actions, like a scale-in or a scale-out event. And it can also be ECS events, like a create service or a delete service event. And speaking about Lambda, Lambda lets you run a function in the cloud. And that function gets executed based on an event. It could be CloudWatch event or an SNS event. And Route 53 is a highly available and scalable DNS service. Private hosted zone is a feature of Route 53, which allows you to hold DNS records and routes requests of a domain that is tied to one or more VPCs. Now, diving a little bit on this implementation, what we have is three microservices that are defined within ECS, and each of those services are fronted by an ELB. And as instances of these applications are created within ECS, they are placed behind an elastic load balancer. When the service gets defined in ECS, they generate a create service event. And this event is picked by CloudWatch events, which then goes and triggers a Lambda function. And the Lambda function will essentially go and register the service into Route 53's private hosted zone, which is a CNAME pointing to your ELB. And that is what the other microservices app needs to use in order to communicate with each other. Now here is another way of doing service discovery using DNS. And in this design, you don't need to specify an elastic load balancer for all of your microservices apps. All you need to do is install a simple agent, and that is ECS SD_agent, which is written in Go. You need to install that on your container instance, and the agent will take care of most of the heavy lifting for you. It automatically registers the service name and all of its metadata, like IP, port info, into Route 53's private hosted zone as an SRV record. If the container stops, the agent recognizes this event because it listens to Docker events natively, and goes and deregisters the service from Route 53. And this agent is available on open source on GitHub, so you can review the source code, customize it, and use it as you see fit. And within this architecture, you'll find the CloudFormation template, and you'll see that we have two ECS container instances running in an ECS cluster, which has ECS SD underscore agent running in the background. And like I said earlier, this agent listens to Docker events natively, and it registers the service name and the tasks metadata into Route 53's private hosted zone. And the agent will also go ahead and re-register the service and its associated SRV record as soon as the Docker container is stopped. So it detects failures as fast as they happen. Let's take a look at another quick demo to see this in action. So what I have here, what I did a couple of days before is I took the CloudFormation template that is available from the GitHub repo, and I launched this stack. And you can take a look at this microservices app that gets built. And this microservices app, it's basically three microservices. One is a front portal for front end, and two other microservices that runs time service as well as calc service. So we want to see if the services are talking to each other. You can just type some calculations there, and it will give you the results. So that means that the communication between portal, calc, and time services is working. And the way it's working is using Route 53, private hosted zone. So now we are on Route 53 management console. You can see I have a domain defined here, which is service discovery. And you'll see that it's got 4 records other than the SOA and NS records. You have 2 SRV records for calc and 2 for time. Now, in order to see the service discovery in action, what we can do is this is the cluster that gets created. What we can do is we can go and minimize the number of tasks that are running within a service and see an update in Route 53. And what we'll do, so you'll see that these are the 3 services that are running within this cluster. So 2 tasks for calc and 2 tasks for time service. We'll go ahead and choose the calc service and update this to say our desired count is 1 task, which means I'm killing 1 task, just to check and see how quickly I can see that event gets updated in Route 53. And I still have 2 running tasks. Let's give it a couple of minutes. There you go. So we see an update, and we can go and check and see if Route 53 is updated. All right, so we see that we only have 3 records now. Let's do the reverse. Let's go ahead and update it to 2 tasks. So I just went and updated the desired count of the service to 2, and then okay, there it is. So I see the update here. Let's take a look at Route 53. We should see the 4 records like we saw earlier. Yep. So you can see I've got 2 time service and 2 calc service. So that gives you a quick demo of service discovery. As the containers get stopped and started, the agent sees that event, it goes and updates Route 53 records, and so on. Now let's move back to our presentation. Now, Vue is a third-party service that allows you to reference containers by their name, like you would use Docker links within your Docker Hub files. And this can be applied across the entire cluster. So Vue doesn't use an external database or a consensus algorithm, but instead it uses a gossip protocol to share group updates about what is running on each host. It also provides load balancing via response randomization. Vue implements an overlay network between Docker hosts, so each packet is encapsulated in a tunnel header and sent to the destination host. The packet goes straight from the user's application to the kernel, and vRouter uses Linux kernel's Open vSwitch model to tell the kernel how to process those packets. And here's another approach, which is, and this is also a third-party service that is built by HashiCorp. Their product by name Consul. It is based on a key value store. As it turns out, key value stores are a really good option in order to store your service discovery metadata information. And Consul works essentially by maintaining a cluster of servers and clients that communicate over Raft protocol. That's another gossip protocol. Let's take a look at the architecture. Consul has a lot of moving parts that are required to make this really dynamic. On each host, you need a Consul server or a client so that the host partakes in the cluster. And you need a registrator container to listen for Docker events and also to communicate them to the cluster. And you also need env console as a wrapper to run as a supervisor process that actually runs inside your container. This is so that if you are monitoring a key value pair and they correspond to some data that your process relies on, like where is my database? env console can reload the environment variables by restarting the process in that container. Now let's take a look at some security options that are available on top of containers. And we'll start with IAM Roles, the feature that we announced a few months back. Previously, you had to define, before we announced this feature, you had to define your IAM roles on top of your EC2 container instances, meaning the IAM policies you assign to the container instance in your ECS cluster had to contain all the IAM policies for the tasks that perform within that same cluster. And this meant that if you had one container that needed access to a specific S3 bucket and another container that needed access to a DynamoDB table, you had to assign both the IAM permissions to the same EC2 instance. Now, with the introduction of IAM roles for ECS Tasks, you can now secure your infrastructure further by assigning an IAM role directly to the ECS Tasks rather than the EC2 container instance. So this allows the EC2 instance to have a minimalistic role, respecting the least privileged access policy and allowing you to manage the instance role and the task role separately. And this is one of the best practices we advise to improve your security on containers. And by doing this, the advantage you gain here is visibility at each task level. You can see which role is using, or which task is using which role being tracked in CloudTrail logs. Speaking about CloudTrail, CloudTrail is a service that captures API calls to AWS services, and it ships log files to an S3 bucket. And this service is readily integrated with ECS service, so you can take advantage of all the CloudTrail logs if you have enabled within your region. CloudTrail captures API calls from the ECS console or from the AWS CLI or the SDKs. Using the information collected by CloudTrail, you can determine what request was made to ECS, the source IP address from which the request was made, and who made that request, and when it was made, and so on. And here's the continuation of the same create cluster event. Now, if you need to do vulnerability scanning on your container images, you can review Twistlock, which is a third-party provider who integrates with both ECS and ECR to offer container security services. Twistlocks provide end-to-end security suite to secure containers from development to production, and the functionality includes vulnerability management, compliance, access control, and runtime defense. Now, with respect to secrets management, there are a couple of options here. The first option is easy to get started, but it's not a recommended approach because you store your secrets as a clear text in your task definitions. The second option is what we recommend. That is to leverage services like DynamoDB, which is a NoSQL service on AWS, or S3 to store your secrets. And you can further enhance this by encrypting your content using the KMS, Key Management Service, before you store your content. And here is a diagrammatic representation of how it will work. You can store your secrets in S3 bucket. You can encrypt it using server-side encryption using KMS. And you can have your application decrypt the key using the SDKs in order to access the secret. And this can be further tied down using IAM roles, VPC endpoints, and IAM policies. Now let's move on to some of the platform as a service or PaaS services that are built on top of ECS. And we'll start with AWS Elastic Beanstalk. And Elastic Beanstalk is a service it's a deployment service that automates capacity provisioning, load balancing, auto-scaling, and health monitoring of your application. You can simply upload your application code that is written in Java, PHP, .NET, Node, and several others, including Docker containers, Docker applications, into Elastic Beanstalk. And Beanstalk will go and build the server environments and loads your application code on top of it. In case of Docker, Elastic Beanstalk take advantages of ECS as a building block in order to deploy multi-container Docker environments. And Elastic Beanstalk is a great way to get started for multi-container applications. So you can take advantage of this because Beanstalk does a lot of heavy lifting for you. So you can focus on your application code. And here is another one, Convox. Convox is an open source tool for deploying, managing, and monitoring applications on cloud infrastructure. And they have a concept of RAC, which is a private platform as a service that is built on top of ECS, is exposed as a REST API. Convox RAC gives you a place to deploy your web application and mobile backends without having to worry about managing service or writing complex deployment recipes or monitoring process uptime. And some of the services that are used here are noteworthy, such as CloudFormation, ECS, ELB, ECR, encrypted S3 buckets, etc. So all the plumbing has been done to have a robust and developer-friendly platform. So developers can readily take advantage of this and start building your containers and deploying them on AWS. And here are some of the commands that you can use in order to get started building your application on Convox. Now another so a company called Remind, they built an open source product called Empire, and this is also available on GitHub. And this is another platform as a service that is very much like Heroku-like workflow, which means you can use the same tools and processes that you use with Heroku, but with all the power of EC2, ECS, and Docker. And here are some commands that shows you how easy it is to get started building an application using Empire. And they actually have a CloudFormation stack so that you can see and build the Empire readily. It's all automated. You can start playing with it if you need to. So that's all I have for today. And here are some of the resources that are available. And like I said, the slides and the presentation will be available on SlideShare and YouTube. So you can take read all the documentation and consume all this information. Now let's take a look at some of the questions. So I see a question here that asks about, can you describe ECS optimized EMI? ECS optimized AMI is a pre-configured and tested AMI on ECS by AWS engineers. It has a minimalistic operating system to get started with your containers quickly on AWS. And I also see there's another question that talks about, are there any CI/CD options with ECS? Actually, there is, and I did not include those in the webinar. But you can search and you'll find multiple options. We have a blog on Jenkins and how to do continuous integration with ECS. And there's also Shippable, CodeShip, Solana Labs. There are some of the CI/CD options that come to mind, but there are multiple options available. And another one that I see here is it possible to do blue-green deployment with ECS? Currently, when you do an update via ECS service, then ECS goes and does a rolling deployment of your task update. And if you have an ELB attached to your service, you can do blue-green deployment by having the same ELB with two target groups, which are two different target groups. And each target group can be pointing to a blue stack and a green service. And after you ensure green stack looks good, or your green service looks good, you can disable your blue target group. And another technique that you can use is you can use the path-based routing that is available on ALB. And you can point one path to your blue stack and another path to your green stack. And you can quickly move the path from blue to green as soon as you know that your green stack is looking good. So that's all I have for today. Thank you again for joining this webinar. And yeah, thanks a lot.
All right, well, thank you, Peter. I'd like to extend a special thank you for running your presentation today and all the great content. And Andrew, thanks for answering all the questions in the Q&A. If you have any comments on the previous or upcoming webinars or suggestions on topics that you wish AWS to cover in the future webinars, please feel free to email us at aws-webcasts@amazon.com. Your feedback will help us improve our webinar programming. So thank you for the audience today for joining us. Have a great rest of your day, and thank you.